Unit 5B, Review of Distance, Position, Displacement, and Time from Grade 10 Science. If you were to travel from home to store, the distance covered, d, would be 10 kilometers. Our position would be 10 kilometers to the east. If you were to travel back to home from the store, your total distance would now be 10 kilometers. Your position, on the other hand, would be 0 kilometers relative to the starting position. Any return trip will have a position of 0 relative to the starting point, or a total displacement of 0. Let's take a look at this example. The skateboarder. At time 0, the skateboarder has a distance of 0 meters from the tree. Its position is 0 relative to the tree, or 2 meters west of the hydrant, or 7 meters west of the sign. At time 2 seconds, his distance traveled is now 2 meters. His position is 2 meters east relative to the tree, or 0 meters relative to the hydrant, and 5 meters west relative to the sign. How about at time 5 seconds? At time 5 seconds, his total distance covered would be 7 meters. His position would be 7 meters to the right of the tree, or 5 meters to the right of the hydrant, or 0 meters relative to the sign. Displacement is defined as change in position. It is a vector. The symbol for position is d with a vector sign. While displacement is change in position, change is denoted by the symbol delta, which is a triangle. Change in position is final position minus initial position. The formula for this is delta d equals df minus di, all with vector symbols. Let's look at this example of the girl rollerblading. Please note the reference point or the origin is not her starting point. At time 0, the distance traveled is 0 meters. Her position is 9 meters east of the hydrant, or 0 meters from her starting position. At 10 seconds, she has traveled a distance of 14 meters. Her position now is 5 meters west of the hydrant, or 14 meters west of the starting position. Now, by inspection, and using some common sense, we can ask you what is her displacement, or change in position, after 10 seconds of roller skating. The answer is 14 meters to the right, or 14 meters west. Let's see how we can calculate this using the formula. Displacement relative to the hydrant. Delta d equals final position minus initial position. Delta d equals df minus di. Delta d equals 5 meters to the west minus 9 meters east. Now, if we were to do the math, 5 meters minus 9 meters makes negative 4 meters, which we've already decided is not her displacement. Her displacement is 14 meters to the west. What is the issue? The issue is these are not the same units. 5 meters to the west is not the same as 9 meters to the east. In fact, they are the opposites. If you remember from our first lesson on vectors, instead of using west and east, we can use positive and negative signs to indicate direction. 9 meters east will denote as positive 9 meters. If you remember, north, up, east, and to the right are often denoted with a positive symbol. That makes 5 meters west a negative 5 meters, the opposite to east. Now if we plug our values in, delta d is negative 5 minus positive 9 meters, which results in negative 14 meters. The negative sign is direction, left or west. In physics, when used with vectors, the negative sign only indicates direction. Time. The symbol for time is t. The unit is seconds, s. Change in time or time interval is indicated by delta t, where delta, the triangle, indicates change. Change in time equals final time minus initial time. The formula for this is delta t equals tf minus ti. Let's go back to our skateboarder. Let's calculate the time interval to travel from the tree to the sign. By inspection, it is obvious that the time interval to travel from the tree to the sign is simply 5 seconds. By inspection, the time interval to travel from the fire hydrant to the sign is 3 seconds. Let's calculate this using our formula. Delta t equals final time minus initial time. Delta t equals tf minus ti. Delta t equals 5 seconds minus 2 seconds. Our time interval is 3 seconds to travel from the hydrant to the sign.